For this problem, we'll use the inverse of a matrix to solve a system of equations. So we have the system 3x plus 5y equals 9 and 2x minus 3y equals negative 13. In part A, we'd just like to express the system in the form ax is equal to b, where A is our coefficient matrix, x contains our variables, and b is our constant matrix. So for part A, if we want to write this in the form ax equals b, we will write it like this. Our coefficient matrix contains the x coefficients of 3 and 2 in that column, the y coefficients of 5 and negative 3. We multiply that by the variable matrix. We have an x and a y. We set that equal to our right-hand side constant matrix, 9 and negative 13. Now in part B, we want to find A inverse, the inverse of this coefficient matrix. So the coefficient matrix is this first square matrix. Here's matrix A. Now we want to find its inverse. So in order to find A inverse, we take 1 and we divide that by, first, we multiply along the main diagonal. 3 times negative 3 is negative 9, and we subtract the product of the other diagonal, 2 times 5, which is 10. And we multiply that by a matrix in which we switch the two elements along the main diagonal. So we switch the 3 and the negative 3. And then along the other diagonal, we just take the negatives of those two elements. So we have negative 2 and negative 5. And we can simplify this A inverse. We'll get 1 over negative 19, or simply negative 1/19, times the matrix containing the elements negative 3, negative 5, negative 2, and 3. And we can rewrite that A inverse by distributing or multiplying that negative 19 through. We'll have our inverse matrix. Negative 1/19 times negative 3 is 3/19. Negative 1/19 times negative 5 is 5/19. Negative 1/19 times negative 2 is 2/19. Negative 1/19 times positive 3 is negative 3/19. Now, we have our inverse matrix. Let's go back for just a moment to part C. In part C, we want to use that inverse matrix that we just found to solve the system. So let's do that. We know that when we started in part A, we wrote down A times X is equal to B. And we wrote down these three matrices. Remember, if you multiply each side on the left by A inverse times A is just the identity matrix. So we have a matrix X, which is our solutions, and that's equal to A inverse times B. So in other words, this tells us to use this inverse matrix that we just got, multiply it by that original matrix B, which was the constants on the right-hand side, and we'll get our solutions. So let's do that. Here we have our A inverse matrix, so we can say that A inverse times B is just equal to, let's rewrite A inverse, 3 over 19, 5 over 19, 2 over 19, and negative 3 over 19, times, remember, those right-hand coefficients that we started with in part A were just 9 and negative 13. So, if we multiply these matrices, let's think about it for just a minute. We have a 2 by 2 matrix, which is A inverse. And we have a 2 by 1 matrix, which is our constant matrix. So because these two middle numbers match, we can do the multiplication, and the order of our solution matrix will be a 2 by 1. So in other words, I have 2 rows and 1 column. I'll just have 2 elements in this matrix. But we need to do a little simplifying to get to those 2 elements. So let's multiply this. First, we'll start with row 1 and multiply that by column 1. We have 3 over 19 times 9. That's just 27 over 19, plus 5 over 19 times negative 13. That's minus 65 over 19. We'll calculate that in just a moment. When we multiply row 2 times column 1, we have 2 over 19 times 9. That's just 18 over 19. Plus, we have negative 3 over 19 times negative 13. That gives us 39 over 19. When we simplify this, 27 over 19 minus 65 over 19 is just 38 over 19, which reduces to negative 2. 18 over 19 plus 39 over 19 is just 57 over 19, which reduces to positive 3. So we can say now that the solution to our system is that x is equal to negative 2 and y is equal to 3. And we can write the solution as the set of the point negative 2, comma 3. And this was the entire answer for part C.